My name is Goos, and I'm a professor of soil science at NDSU. And I've been in NDSU since 1980. And over the years I have worked on many issues related to soil fertility and fertilizers. But since 1997 I've been working on a lot on iron deficiency chlorosis of soybeans. Iron is the most abundant nutrient in the soil. In the root zone of a soybean plant, there is like 300,000 or 400,000 pounds per acre of iron. But a field of soybeans like this will turn yellow for the lack of a few grams of it. So the problem is there's no lack of iron in our soil, total iron, but the problem is at pH 8 or thereabouts, the solubility is very low, and then the bicarbonate in the soil solution makes it hard for the soybeans to move it around. Dr. McLean showed in his genetic studies that the genes for chlorosis resistance not only involve acquisition of iron, but the translocation of iron. So it's a very, very complicated problem. Obviously, it's more of a problem in the Red River Valley. But even if you get out of the Red River Valley, you can have high water soils and areas in a field with iron deficiency chlorosis. Most nutrient deficiencies affect the bottom leaves first. But iron is a unique problem because it affects the upper leaves first. And what happens is if iron deficiency chlorosis is severe enough, the upper leaves and the growing point will be damaged, and then the plant just can't continue. By contrast, nitrogen affects the lower leaves and not the upper leaves first. So a rescue treatment for nitrogen is much more effective than a rescue treatment for iron, because once the growing point is damaged, the crop is severely damaged. Well, one thing we've learned over the years is that the control measures for IDC are stackable. The foundation is a resistant variety, and NDSU provides good guidance and field studies on how to select a resistant variety. But even a resistant variety can have yellowing. So if you have a resistant variety, what do you stack upon it? Well, one thing you can stack upon it is an in-furrow treatment of an effective iron fertilizer. Now, the first one on the market was called Soy Green, but there are others on the market today that are effective as well. So resistant variety and in-furrow treatment of an effective iron fertilizer, and then if that's not even doing the trick, going to wider rows, 22 or 30-inch rows, and maybe a heavier seeding rate. Those are the three, that's the current practice. That's what we know now. And what I'm trying to find out is, what can I add in addition to a fertilizer like Soy Green to combat chlorosis? We know so much more about chlorosis than we used to know. We know a lot about what the syndrome is. So for example, in this experiment, I've got a control with just a control, and here I've added a very low rate of Soy Green, and then in this experiment I'm also studying growth regulators to combat some of the other issues that have to do with chlorosis. For example, chlorosis is a lack of chlorophyll. Well, what if we combine Soy Green with a growth regulator that stimulates chlorophyll production? Or there are toxins that accumulate in the plant during IDC. Well, what if we combine Soy Green or an iron fertilizer with a compound that stimulates the enzymes that decompose those toxins? That's what I'm trying to look for. You know, we know to use a strong variety. We know to use an in-furrow fertilizer. My project here is, well, what can we stack on top of it?